Alright, this is some video instruction for tests that were on Test 4 exam, and they weren't on the review or in the homework. And I did not catch that, so I gave everyone 5 points on the test for free on test number 4. Anyway, these problems, what they're trying to tell you or get you to see is that if you're looking at the area of the large square, you're going to do this total length times this total width. If you're looking at the area of a large square. You can also look at the area of this large square as the addition of 4 smaller squares. If you took the area of this square right here, and then the area of this square, and etc., and this square, and then this square, if you add each of those areas, you would get the area of the total square. So there's 2 ways to approach this problem. And there's 2 problems back to back that are with this similar kind of drawing. In this situation, they give you the area of the small squares. That's what these numbers are. Y squared is the area of this square. 5y is the area of this square. 20 is the area of this square down here. And then 4y is the area of this square here. So, when you're asked to find, well, what does A equal? If the area of this square is y squared, and we have to do length times width of the smaller square, C times A has to equal y squared, well then C and A must be y. C times A is y squared, so A is y, C is y. For this one, what does B equal? Well, you're looking at the length of this line here as what you're going to multiply times the width of that line for this area, 5y. We already know that C equals y, so this 5 must be B. That must equal B. 5. Because 5 times the y, C equals y, is the area of this little square. Whoops. Yeah, so B equals 5. All we have left to find is D. What we have is we have to find the length of this segment, just this little segment, times this segment. Now this segment is the same length as this segment and is the same length as this segment. So all of those we have already determined equals y, because C and y, A are y. I hope this is not too confusing. So if this length is y, then this length is also y. So if it's 4y, then you multiplied y times this, which is 4. So D equals 4. And that's how you get 4y as an area. 4 times y. Make sure that looks like a y. So D is 4. And the area of the figure, what they're trying to say, write the entire area of the figure as a product of 2 binomial. Okay, so what they're saying is you add this segment, and there's all these colors here. We're going to add this segment to this segment of line to get the total line. So A plus B is this total line. Well, A is y, b is 5. So we have y plus 5, and that's going to be our width right here. This is y plus 5. Okay, because this segment is 5, this segment is y. Now for this total length of line, you have these two segments again. One segment is y and the other is 4. So your other side of the larger square is y plus 4, which is why you have a product of two binomials. These are the binomials, and when you multiply binomials, those are factors that will equal, when multiplied, they will equal a product, because any two numbers multiplied gives you a product, or any three numbers multiplied, doesn't matter. If you multiply, you get a product. So how do we multiply these? And a lot of people are very good at doing FOIL. We don't have problems with that. But that's what we do. We just FOIL the answer to get the area of the figure, and it is in terms of y. So of course you get y squared, and everything is positive, so it makes it easy, plus 4y plus plus 5y, and then plus 20, because 5 times 4 is 20. So 5y plus 20, which then of course gives you a total of y squared, 9y plus 9y plus 20. So that's how you approach that problem. And then I'll do another one just like it, but in the opposite way.